Alright, for our seminar video, interactive learning assignment 2, we are to do section 8.4, number 49. Okay? So, we have a problem, an IVP problem, which is initial value problem, where x dy dx equals x squared minus 4, where x squared equals to 2, and the other condition is the initial value of y at 2 equals 0. Okay. With that being said, we can say that dy dx equals nothing more than square root of x minus 4 over x. Then we can take the integral on both sides and get y equaling the integral of x squared minus x over x dx. Alright, from here we're going to use a little bit of trig substitution for this triangle of x squared minus 4. This is x, this is 2. And this comes from the general form of x squared plus y squared minus equals a squared. Or vice versa, depending upon how you do it. Okay. So, with that being said, we can make the relationship secant theta equal x over 2. Note this is for respect to theta. Okay? And tangent theta going to x squared minus 4 divided by 2. Alright? We can also say that, oh, by the way, that means 2 secant theta equals x. Alright? And the 2 tangent theta equals x squared minus 4. Looking at our equation, y equals the integral of square root of x squared minus 4 over x dx. Y equals the integral of 2 tangent theta right here divided by 2 secant theta. Alright, and let's find d theta, the relationship between dx and what's going to be d theta. Secant theta equals x divided by 2, which means arc secant theta of x over 2 is equal to theta. Alright? Alright, so that means your d theta well, actually we don't have to go that way. We can actually just say 2 theta. 2 secant theta still equals x. But dx equals to 2 secant theta tangent theta because of that identity there. Okay? So our new equation for this dx is y equals the integral of 2 tangent theta over 2 secant theta times 2 secant theta tangent theta d theta. And these can cancel out, this secant and this secant, this 2, and we're left with y equaling 2 times, because we still have that 2 there, tangent squared theta e theta. Alright, and because of the identity, well, because of another identity, with secant squared minus 1 equal to secant squared theta minus theta, well, minus 1 equals tangent squared theta. So we have y equals 2 times the integral of secant squared theta minus 1 d theta. Alright? Y equaling 2, we're going to evaluate this, times tangent theta, because the integral of secant squared theta is tangent theta, because tangent theta's derivative is secant squared theta, minus theta, plus your constant c. C is arbitrary constant number, so we don't need to multiply by 2 times c, because it's just a holder for a constant value, which we're going to find in a couple minutes. Okay, so in that case, we're going to say that y equals 2 tan theta minus 2 theta plus c, and then we can come right back and say that tangent theta equals the square root of x squared minus 4 minus 2 theta, which we found to be, here we go, we can just make it again, theta equals arcsecant of x over 2, which is equal to theta, minus 2 arcsecant of x over 2, plus your constant c. Also, we do know that with our initial value of y of 2 equaling 0, and we can set y equal to 0, then 2 squared x equals 2 squared minus 4 minus 2 arcsecant of 1 plus c. This goes to 0. And I want to show something really quickly before I have to do any weird things with this. Since 1 over 1 is still 1 over 1, we can say that 1 over arcsecant of 1 equals arc cosine at 1 only for when that value is equal to 1, correct? Alright, so from there we can go on into use your unit circle, handy dandy unit circle to find this out, and where arc cosine is 1, arcsecant and arc cosine are just 0. So this goes to 0. So c equals 0. So we don't have, well, CRC equals 0. So our equation is just equal to the square root of x squared minus 4 minus 2 times arcsecant of x over 2. And that's your answer. And thank you all for watching.